Hey kids, welcome to section 6.8, solving logarithmic equations and inequalities. Today I'm going to teach you how to solve logarithmic equations and logarithmic inequalities. So a logarithmic equation contains one or more logarithms. You can use the definition of a logarithm to help you solve logarithmic equations. So for instance, there's a property called the equality for logarithmic functions. It says that if you have log base b of x equals log base b of y, you can set x equal to y. So if you have a log on both sides and they're both the same base, you can use that to solve the equation. So let's see how that works. Well, letter A doesn't have two logs on either side, so we need to change logarithmic to exponential. So we're going to take 9 to the 3 halves power equals x. Now remember, 9 to the 3 halves power means the square root of 9 raised to the third power. And so the square root of 9 is 3, and 3 cubed is 27. Remember, you can check it by substituting 27 in for x and see if you get 3 halves. Letter B, the first thing I need to do is add 4 to both sides. So this is x equals log base 3 of 243 plus 4. Remember, log base 3 of 243, I can simplify and say log of 243 divided by log of 3, and then I'm adding 4. Well, if I do log of 243 divided by log of 3, I get 5. And so x equals 9. There are lots of different ways you can do these problems. These are just one way. All right, if I look at letter C, notice that I have log base 9 on both sides. That means I can take what's in the parentheses and set it equal to each other. So 3x squared equals 2x plus 1. Now I notice I have a quadratic, so I need to get everything on one side. So I'm going to minus 2x to the left side, and I'm going to minus 1 to the left side, set it equal to 0. If you have a quadratic set equal to 0, you want to try to factor it. So I know the first things in the parentheses have to multiply to give me 3x squared. So that means one of them is 3x and one of them is x. Then the last things in the parentheses have to multiply to give me 1, or negative 1, I should say, which means they're both 1s, and one of them is negative and one is positive. So I'm going to guess the negative goes in the second one and the positive goes in the first one. Remember, you can double distribute and see if what you factored is correct or not. That's why it's called guess and check. Once I have my two parentheses multiplied to equal 0, I set each parenthesis equal to 0 and solve. Now the one on the right is much easier. You can add 1 to both sides and you get x equals 1. The one on the left, I need to subtract 1 over to the other side to get 3x equals negative 1. Divide by 3 and you get negative 1/3. Now keep in mind that when you substitute that value back in, I cannot get a negative in the parentheses. If I do, that means that answer is extraneous because I cannot take the log of a negative number. So if I plug negative 1/3 in, I'm fine on the left side because when I square a negative number, it becomes positive. But on the right-hand side, 2 times negative 1/3 is negative 2/3. But if I add 1 to it, I get a positive 1/3. So actually, x equals negative 1/3 does work. If I plug in 1, I get a positive on the left and I get a positive on the right. So in this case, both work. Sometimes both will work, sometimes neither will work, sometimes one or the other will work, and the other one won't. If I look at letter D, log base 4 of 4x minus 20 equals 5. Notice I only have a log on one side of the equation, so I'm going to change this to exponential by doing 4 to the 5th equals 4x minus 20. Now 4 to the 5th power is 1024 equals 4x minus 20. I can add 20 to both sides. This gives me 1044 equals 4x. Divide by 4. and you get x equals 261. Again, you can substitute that value back in and see if what you get is close to 5. It's not going to be exactly 5 because we rounded somewhere. Or in this case, I guess we didn't round, but in a lot of the other ones, you will have rounded, so you're not going to get exactly what's on the other side. Okay, so that's logarithmic equations. Now I'm going to talk about logarithmic inequalities. Now you need to be careful whenever you do anything with inequalities. We've already seen that you need to make sure that you multiply or divide by a negative number, that you flip that inequality. But the other thing we need to be aware of is that you cannot take the log or the natural log of a negative number. So whenever you're dealing with inequalities, you have to make sure that the answer that you get is not going to make the parentheses thing after the log or natural log a negative. There are also some other rules that you need to follow. If you're dealing with a log just on one side of the inequality, so log base b of x is greater than 0 or greater than y, I can change it to x is greater than b to the y. If I have log base b of x is less than y, then I'm going to turn it into this compound inequality, 0 is less than x is less than b to the y. So you need to be very careful when you only have one log. If you have two logs on both sides of the inequality, this makes it super easy, because if log base b of x is greater than log base b of y, then x is greater than y. If log base b of x is less than log base b of y, then x is less than y. So the only ones you really need to be careful of are when you only have a single log in your inequality statement. Then you have to do some funky stuff. So let's take a look at some examples. Letter A, solve the inequality. Log base 16 of x is greater than or equal to a half. So remember, if you have a single log, I need to look back at the rules. I have a log is greater than. So I need to rewrite this as x is greater than by. X is greater than b to the y. X is greater than b to the y. So my x, let's make sure we have this right. Log base b of x is greater than y. Log base b of x is greater than y. All right. So I can take my x, which is x, is greater than my base, which is 16, to the y, which is a half. And now I get x is greater than the square root of 16, which is 4. I do also have to make sure that my x value is greater than 0. So if I look on a number line, here's 0, here's 4. I'm looking for where 4 is greater. I also want 0 greater than 0. So I'm looking at this part right here, which means x is greater than 4. So you're going to have, oh, I guess it's equal to. My bad, I lost all my equal to's. So you are going to have to look at some number lines in order to figure out how all the different constraints work together. All right, if we're looking at letter B, now we have a single log with a less than. So I'm going to be doing 0 is less than x is less than b to the y. 0 is less than x is less than b to the y. So if I have log base 5 of negative 3x is less than 1, then I'm going to say 0 is less than x, which in this case is negative 3x, is less than b to the y, so 5 to the 1. So this gives me 0 less than negative 3x less than 5. I got to divide everything by negative 3. When I do that, my inequality is going to reverse because I'm dividing by a negative number. So this gives me 0 is greater than x is greater than negative 5/3. And that looks kind of weird. 1, because the inequalities are pointing the wrong way. And 2, the smaller number should always be on the left. So if I flip it and say negative 5/3, I need to reverse the inequalities. And now I get negative 5/3. Ooh, my bad, not yet. Negative 5/3 is less than x is less than 0. I also want to make sure that my negative 3x is greater than 0 because I can't take the log of a negative number. So this gives me x is less than 0. So if I take a look at a number line, here's negative 5/3 and here's 0. I want between negative 5/3 and 0. And my one constraint is that it must be less than 0. So I'm looking for everything in between. So negative 5/3 is less than x is less than 0. All right, if we take a look at letter C, log base 9 of x minus 1 is greater than log base 9 of 2x. If I have two logs, it becomes really easy. All I have to do is just grab the x minus 1, the greater than symbol, and the 2x. And then I solve this. So let's see, minus x to both sides. Negative 1 is greater than x. That looks kind of weird, so we're going to say x is less than negative 1. I also have to make sure that my x minus 1 is greater than 0 and that my 2x is greater than 0. So the one in the middle gives me x is greater than 1. The one on the right gives me x is greater than 0. So if I look at negative 1, 0, and 1, my main inequality is less than negative 1. My middle inequality says greater than 1. My far right inequality says greater than 0. They don't overlap anywhere. Therefore, this is no solution. If I look at letter D, log base 10 of 2x minus 2 is less than log base 10 of 7 minus x. Again, I have a log on both sides, so I can just say 2x minus 2 is less than 7 minus x. See, add x to both sides. That gives me 3x minus 2 is less than 7. Add 2. 3x is less than 9. Divide by 3. X is less than 3. I do have to check my other constraints. 2x minus 2 has to be greater than 0. And 7 minus x has to be greater than 0. So in the middle, we get 2x is greater than 2. X is greater than 1. On the left, or on the far right side, negative x is greater than negative 7. X is less than positive 7. So we got 1, 3, 7. My main inequality is less than 3. I also have a greater than 1 and a less than 7, which means I'm overlapping between 1 and 3. 1 is less than x is less than 3. All right, let's see some more examples. All right, in letter A, log base 7 of x is less than negative 1. So this is the situation where we have 0 is less than x is less than b to the y. So we have 0 is less than x is less than 7 to the negative 1. So that's 0 less than x less than 1 over 7. I do have to make sure that x is greater than 0. Here's 0, here's 1/7. My main inequality is between 0 and 1/7. My constraint is that it's got to be greater than 0. So I'm looking between 0 and 1/7. Okay, if we look at letter B, log base 9 of x squared minus 4x equals log base 9 of 3x minus 10. Well, I have logs on both sides and an equal sign, so I just grab the stuff in parentheses. X squared minus 4x equals 3x minus 10. I see a quadratic, so I need everything on one side. So I'm going to minus 3x and add 10. So x squared minus 7x plus 10 equals 0. I can factor this, so this gives me x minus 5, x minus 2 equals 0. Multiplies to give me 10 and adds to give me negative 7. So this gives me x minus 5 equals 0, x minus 2 equals 0. So x equals 5 and x equals 2. So check to make sure that if you plug them in, they don't make the parentheses things equal to or less than 0. So if I plug in 5, 5 squared is 25, minus 4 times 5 is 20, so that gives me 5. That's good. 3 times 5 is 15, minus 10 is 5. Okay, that one's good. If I plug in 2, 2 squared is 4, 4 times 2 is 8, 4 minus 8 is negative 4. Ooh, that doesn't work. All right, if we look at letter C, log base 5 of x squared minus 10 equals log base 5 of 3x. Logs on both sides, equal signs. So I set x squared minus 10 equal to 3x. It's a quadratic, so I'm going to move the 3x to the left side. X squared minus 3x minus 10 equals 0. I can try to factor x and x. Two numbers that add to give me negative 3, but multiply to give me negative 10 would be negative 5 and positive 2. So this gives me x minus 5 equals 0, or x equals positive 5. X plus 2 equals 0, or x equals negative 2. Check to see if you plug them in if it makes it less than 0. If I plug negative 2 into 3 times negative 2, I get negative 6. Doesn't work. If I plug in 5, 5 squared is 25. 25 minus 10 is 15. That works. 3 times 5 is 15. That works. So my answer is x equals 5. All right, letter D, log base 11 of 3x minus 24 greater than or equal to log base 11 of negative 5x minus 8. Logs on both sides. So I just grab the parenthesis things and set it greater than or equal to. 3x minus 24 is greater than or equal to negative 5x minus 8. All right, let's move the 5x to the left. So that gives me 8x minus 24 is greater than or equal to negative 8. Add 24. 8x is greater than or equal to 16. Divide by 8. X is greater than or equal to 2. I also have to make sure that 3x minus 24 is greater than 0, and negative 5x minus 8 is greater than 0. So in the middle, I get 3x is greater than 24. Divide by 3. X is greater than 8. In the far right one, I'm going to add 8 to both sides. So negative 5x is greater than 8. Divide by a negative 5. So x is less than negative 8/5. If we pull out a number line and we put negative 8/5, 2 and 8, my main inequality is greater than or equal to 2. I have a greater than 8 and a less than negative 8/5. Well, nothing overlaps, so no solution. All right, we have two word problems to talk about. First one has to do with speed of winds. The equation for wind speed W in miles per hour near the center of a tornado is W equals 93 log base 10 of D plus 65, where D is the distance in miles that the tornado travels and W is the wind speed. In May of 1999, a tornado devastated Oklahoma City, the fastest wind speed ever recorded. If the tornado traveled 525 miles, estimate the wind speed near the center of the tornado. Is your answer reasonable? Well, this 525 miles is how much they traveled. D is the distance they traveled. So we're going to substitute 93 log base 10 of 525 plus 65. Well, this is nice. All this stuff on the right side can be plugged into a calculator, and I get 318 miles per hour. Now, it wants to know if the answer is reasonable. So I did a little research. The average speed of a tornado is 100 miles per hour. So a 300 mile per hour wind is going to be a really big tornado. So we can say it seems high as the average speed of a tornado is 100 miles per hour. Seems high. Okay, we got one more word problem. This one has to do with pianos. The first note on a piano keyboard corresponds to a pitch with a frequency of 27.5 cycles per second. With every successive note, you go up the white and black keys of a piano. The pitch multiplies by a factor of 12 through root 2. The formula for the frequency of the pitch sounded when the nth note up the keyboard is played is given by n equals 1 plus 12 log base 2 of f over 27.5. The pitch that orchestra is tuned to is the A above middle C. It has a frequency of 440 cycles per second. How many notes up the keyboard is this A? Well, this is frequency. Frequency is F. So we're going to replace F with 440. So this becomes n equals 1 plus 12 log base 2 of 440 over 27.5. So let's see. I can use my calculator and divide 440 by 27.5. N equals 1 plus 12 log base 2. And if I do 440 divided by 27.5 on my calculator, I get 16. Well, then I can calculate what log base 2 of 16 is. So 1 plus 12. And then remember, I can do log of 16 over log of 2. So this gives me n equals 1 plus 12. And if I do log 16 divided by log 2, I get 4. So this becomes 1 plus 48, or the 49th key. All right, if you guys have any questions, please let me know. And as always, keep calm and keep trucking.